Hi everyone. Today we're going to talk about valuation, focusing on bond valuation and stock valuation using Excel. As you see here, when we do basic valuation, we are in need to know the present value of the future stream of cash flow expected at the end of the year. So we're going to do bond valuation by giving you the three scenarios for the bond valuation. So we will assume that we will have the face value of the bond, which is 1,000. The given coupon rate based on the agreement is 10%. So if we do this 10% times the 1,000, which is the bond value, this will give me 100. Given that the market rate or the required rate of return in the market is 10%, and the numbers of years for this 10-year is 10 years. So we have to do two things. Find the present value of the PMT, which is the coupon installments or payments. So we are going to use present value. As you see here, we're going to click PV, the present value. We're going to click. So if we are going to write it from the beginning, so we are going to write present value, and then you are going to select the market rate, required rate of return, the numbers of years, and then the PMT that you're going to pay, which is the 100, and then you're going to click enter. This is the first part. So the first part is the present value of the PMT. The second part, which is the principal, which is the 1,000, the face value. And here you're going to find when you are going to discount it. So you are going to say equal PV, and then you are going to click for the rate, basically, and then go for the numbers of years, and then the 1,000, which is the bond par value that you are going to have it here. So here we did the discounting, and we did the present value of this 1,000, and then it give us the present value of this item, which is 6,000. Here you see that it is not correct. Why? Because when you go for the PMT, you have to put here 0, one of the mistakes that we do. So we have to put 0, then the face value that you have it here, and then you will find it correct. It is comma, not semicolon. And this is one of the things that you have to look for when you are doing your calculation. Here it's correct. So I intended to do by mistake to tell you when you're going to do the second one, you have to do it by putting it and the future value that you're going to receive. So the sum of them is 1,000. This is one way, or you can do it in just one step. But in the one step, you are going to plug all the variables in one items. So how we are going to do that? So you are going to look for it, present value, and then when you do this present value, you have to pay attention for the rate, required rate of return, and the number of years. And then here you pay attention to the 100, which is the PMT, and then finally the bond par value at the end, which is going to give you the same answer. So this is the same way. So if the required rate of return, it is different. Let's say, for example, it is 8%, and the coupon rate, it is 8%. So this is what we call it finance with the face value, bar value equal to the face value. So I will do another one, which is that you are going to finance for your bond valuations with the lower cost. How you are going to do that? We are going to do that by focusing on the same steps. But here you will see that the bond value is completely of the coupon rate is completely different than the required rate of return. And the required rate of return here, it is higher than the coupon rate, which is 12%. And then this 12%, it is higher than the market rate. So when you are going to discount it, you will find that you are going to find it with a lower cost. So here it is the same step. You're going to look for the present value here. You plug in for each item of them. We start by the rate, market rate. Pay attention for this, usually market rate. And then the numbers of years, it is 10. And then we go for the first part, which is the PMT. So don't forget to make it with a negative because it is an outflow. And then you can click enter. The present value, it is the same. Pay attention to the PMT, and then all of them all of a sudden. Or either in one step, you plug all the equations, and you will find that it is 887, which is lower than the par value. So let's give another calculation. If it's say it is become 14%, so here it is, you are paying or financing it with a lower cost. Last but not least, if you are going to make a coupon with a 10%, or let's say, for example, 5%, doesn't matter, and all of a sudden the market rate has to pick up and increases to 15%. So here, 5%, and this is 15% required rate of return. So you have to pay attention for the required rate of return here. So here it is the coupon rate, which is 10%. So I will make it higher, and then the rate of the market has been changed to, if it's 20% and the market rate, it is become 10%. So you will see here that you make an agreement on coupon rate with a high rate. So this is what we mean it with higher cost. And then we go for discounting both of the items, the PMT and the lump sum of the bond value. Then it is giving you a value greater than, this is 1,600. It is greater than the 1,000. And this is what we call it, we finance it with a higher cost. Let's go after that. We do the three scenarios. So you have to pay attention for each one of them. And this is what you do bond valuation. We have another terminology which is called the bond yield. On the other hand, is a broader term that encompasses measures of the return on investment. You see here, it can be referred to different items. It can be referred to yield to worst, can be referred to yield to maturity, yield to call. And let's differentiate between the three types of yields. Yield to maturity. The meaning of yield to maturity represent the total return anticipated or expected until you become mature. This is yield to maturity. And this is what we're going to solve for right now. Taking into account the price of the face value of the bond and the coupon paid. So how much it will be at the end. So this is the yield to maturity. So in the yield to maturity, the present value of the bond itself, 1,600. It is 2,000, doesn't matter. So this is the present value. And the future value of it is 1,000. And the numbers of years, let's say it is a 15. And the coupon rate that you did it, and you sign for it, it is a 10%. So the coupon value here, so it is a 10% times 1,000. So it is the coupon value, how much it is. This is the coupon value, and it is 500. How much about the bond yield itself? How much is the difference between what you pay and the yield to maturity here? It is the total return, anticipated total return. So how much you gain from this? The bond yield here, it is representing by the coupon values here with respect to the 2,000 of the present value of the coupon, which has been given here in this example. فهنا 2,000, and the yield to yield to maturity, it is a 5%. Also here, if let's say, for example, here current this is the yield to maturity. Let's go for the current yield. What is the current yield here? So in order to find the current yield, so the present value of the bond itself, we calculated, giving you the present value here. It is need to be calculated. It is in, and the future value, it is 1,000 in the future. Number, it is 7, and the coupon, that is the current yield, And here you need to find the rate of the value of this bond with respect to the bond itself. So it will be the 7th, and the coupon rate is given 9%, and the volume, or the value out that you're going to pay, which is 9% times the 1,000. So it is 90, and the rate here, it is 8%. That is what we're going to discount rate in the markets. So when we go for do that, we need to do it in 2 steps. So the first step, we need to find the present value first. So the present value of what? The present value of this payment. And as you see here, we start by the first cell, which is 57, which is the rate of the market. Yield to maturity, which has been given here. How much they yield this to maturity? It is 8%. And then go for the numbers, and number of the payment, 7. And the PMT, which we calculated, 90. And then finally the 1,000. So the present value of this bond is 1,052. So when we need to find the current yield, So this current yield, it is by dividing what we call it the 90 with respect to the present value. So the yield to maturity represent the return anticipated. Yield to call, it is similar to the yield to maturity, but here the left, the issuer before maturity, how much numbers of years before maturity. Yield to worst, which represent the lowest potential yield an investor can receive, the lowest, the minimum, taking into consideration some factors that affect the possibility of this return. Also, the bond evaluation, it can be done in semi-annually, quarterly. So when we have it semi-annually, so we need to take care about dividing it by 2 because the payments here will be divided by 2 times. And the coupon value, instead of having it, this is a total amount here, how much it will be, the coupon value. So if it is 6%, so 6% times 1,000 divided by 2, so it is 30. The same way for any semi-annually. Required rate of return, which is semi-annual in the market, here it was 8. And then, so we need to divide it by 2 numbers of years here, let's say, for example, 2 or 3 or 4, whatsoever. Then we can find the present value similarly quickly by doing the same scenario. And here, if you look here, it is with a premium or discount or with a par value. So here you find that the present value, the current or present value that we are going to have it here, it is less than the 1,000. Since it is less than the 1,000, so we name it, it is discount. So we finance it with a lower cost. If it is higher, let's say, for example, we go up. So here it is par value, here with a discount, and here with a premium, which is the higher value. So this is what we have here for the bond valuation. Let's go to the stock valuation. So in the stock valuations, it's very interesting. We're going to do the stock valuation for the preferred stock and the common stock. So for the preferred stock and the common stock, you have to know that we are finding the present value of all the coming dividends. So we will start with the easiest one, which is the preferred stock. And sometimes we say that it is perpetuity, which is lasts for a longer number of years. So here, let's say that my face value of this preferred stock is 100, and I own it for infinity. So just 200, 150, doesn't matter. It will give you the same values, it doesn't matter. So here we have to know the PMT, which is, have to go here, the PMT بالنسبة لي أنا, it will be the DEV, how much the DEV is. So here it is 5% from this 100, so it is a 5%. How can I calculate 5% times the 100? It can be, let's say, change it 7%. So if we are going to find it, so it will be 7% here. So 7%. Okay. So this will be the 7%, the dividends, and the required rate of return here in the market. Let's say it is 9%. So the 7% is just to calculate for it the DEV, the 7%. This is a 7%, 7% from the total 100. So 7%, how much it is? So the 7% times the 100, it will be 7. And the required rate of the market, it is 9%. So what we are in need, we can plug in the equation to find the present value. We write 100 years, 200 years, it doesn't matter. Consequently, the present value, which is the rate, which is the 9%, followed by the numbers was 150, 200, whatsoever, and then the sevens or whatsoever it is, it's giving you the value. So this is the preferred stock. Mathematically, it can be done quickly and easy by just clicking on the two values, the DEV, just the DEV over the required rate of return, and that's it, the DEV over the required rate of return. So this is for the preferred stock. Let's go for the common stock, which is the interesting part. So in the common stock, you here see that we have 3: zero gross model, constant gross model, variable gross model. So the common stock, no growth at all. So I expect to pay dividends, just one dividends. And I'm going to sell it for, let's say, for $50. And the numbers of years here, it is 1. And the required rate of return in the market is 14. So it is very simple that you can find the common stock. So by doing the present value, so here, if you see, you will find that the required rate of return, which is the first item. I click on the required rate of return, and then the numbers of years, which is here. I'm going to keep it just for 1 year. And the PMT, which is $1, simply $1 I'm going to have. And the future value of the selling of the stock, which is the 50 that I'm going to have. So if I have it by this way, so let's say if I put the stock is 2, dev of the stock is 2, and then I'm going to plug in to find the present value. So this is a simple way. Or I can do it by formula by doing what? The future value of this $2, which is of the selling prices, which is 50 plus the $2, that be 44. This is the selling price plus the $2. And then I'm going to discount them 1 over the discounted rate. This is very, very simple way. So it will give you the 2 approaches. The easiest approach, you do discounting, simple discounting. You discount what? You discount the 46, the required rate of return, discounting at the required rate of return 14, and then 45 numbers of years. Selling prices here, it is the selling prices I am going to keep الستوك بتاعي ده for just 1 year, and this is the present value. As well, expect to pay dividends here, the dividends here at year 0, and I'm going to sell it for $31 or for $50, and the numbers required rate of return 14%. common stock, simply I'm just going to discount, and I'm just keeping it, and I'm مش بوزع dividends. No dividends going to be distributed. So here it is the present value. So I required rate of return 14, and then followed by the 45 numbers of years. I'm going to sell it next year. And then there is no dev here, which is the PMT. And then finally, the selling price, which is giving me 43. It is the same if I'm having a future value, I'm discounting it with respect to the common stock. So this is what we call it zero growth model. What happens if I have constant growth model? So in the constant growth model, you will have the new dividends over R minus G, the R, which is the required return, and the gross rate that we're going to look for. So basically here, I'm expecting to have a dividends by $2, and I'm going to sell it for $50. And the numbers of years, I will keep them for 3 years. And the growth rate is 10%, and the required rate is 14%. So here I'm in need to find the constant growth model. So we're going to prepare our year plan. So here we have 3 years, 1, 2, 3, and then we start by $2, and then it is going to grow by a growth rate 10%. Either you are going to use it like that, or you can say it is equal to times the growth rate, which is 1.1, which is going to give you the same way. It is the same way of the same calculation, so it is 2.2. The next one, I'm going to say that this 2.2 will be how much? So I will say 2.2 times 1.1. It will give me the 2.42. This is very simple and very easy. It depends on the rates that you are going to have. Okay, so what happens if I have it for just the 3rd year, and the value of the stock, let's say, for example, it has become 35 or whatsoever it is, 35. Let's change it. So let's say here it is 50, and here it is 50. So let's say it is 35 here, for example. So I may need to find the present value. To find the present value, I have to focus on each year stream. What is each year stream? This is the first year, 2. Second year, I'm going to receive 2.2. The last year, I'm going to receive both the dev and the selling price of the stock. Perfect, 37. So I can do it by saying the discounted value. I discount each step of them according to the required rate of return, 14% required rate of return, or simply this is the sum, or I can do it in another way. This is the sum, or I can do it in the terms of what? We can do it in the terms of NPV. So how you are going to do that? We are going to write it NPV, which is the easiest and fastest, 14%. And this is the stream of money that I'm highlighting upon. And that's it. So it's giving me the same answer. So it is the same. So I will use the same formula, not sterling, it is dollar. So I just use the NPV. So both of them are correct. Either you're doing by step or just one click by using NPV. Let's go for common stock with a constant for infinity. So here it is very interesting to go for it for infinity, which is the dev that I'm going to receive it. I am going to receive a dev, $2 for infinity. Simply R minus J. So I'm going to do what? I'm just to have to divide it, the two dividends divided R minus G, which is 15 minus 5. So it's giving me the $20. Simply, this is called a constant growth to infinity. Let's go to the most interesting one, which is the common stock with the variable graphs. Let's say I'm going to receive a dividends 3 or 2. It's in place that I didn't activate it, 2. And the numbers of years here, let's say, for example, NBR, it is 4, and it is 10%. And the growth rate, the second growth rate from the third year. So the second growth rate will be from the third year, so pay attention for it. And it will last for with me for infinity. So the required rate of return is 14, and I need to find the common stock, how much it will be. So as you see here, it is, I'm going to expect it to pay that by 2. So this is the numbers of years. This is my plan. Okay. Number of years is 4. The growth rate, it is 10%. And the growth rate from the third. What do you mean by the third? So it is 2 for the first year. 2.2 times 10%. And for the first year, second year, and this is for the growth rate, which is the 10%. How long I'm going to last with this? I'm going to last with this for the first 3 years. So I will highlight this by the 3 years based on the growth rate. And the growth rate from the third, we are going to receive another growth rate, which is the lowest growth rate. So here it will be 2.52. How can I got this? I can do it like that by 2.42 times 1.05. It will give me, 2 times 4%, not 5%. I did it wrong. 4%. 4%, it will give me the correct answer. So times the growth rate, or you can do it by the formula, which is you're going to take the 2.42 times the growth rate with the power 1, and then the growth rate times with the power 2, and it lasts for the growth rate 2 from the third year, and it lasts for 3 years, and then I'm going to sell the stock. Let's say, for example, I need to find it for that lasts for 3 years, for the third years, and then it's going to change after that. Growth rate from 2 from the 2 to the third. So I have 2 growth rate from the 2 to the third. For here, the growth rate 2 to the third, يبقى fourth, fifth, sixth. So I have lasted for 3 years, and then it's going to be changed after that. So here, the growth rate in the fourth year, it will be 4%. So here it is extra data. We mention here the growth rate for 3 years, and then from the fourth and fifth and sixth, it will be 4%, and then it's going to be changed. In this last year, this is the given data, and then it's going to be changed for infinity. So let's say, for example, here I'm going to use the constant growth rate, which is R minus G, R minus G. So when we have this R minus G, so it is 38. So this is the auto sum. This is the stream that I'm going to receive, which is I'm going to highlight. This is the stream. 2, 2.2, 2.52, and so on. This is the stream. I can do it by discounting each one of them. I discount with what rate? I'm going to discount with the given rate, 14%. So I put the dollar sign between the 14% to make it constant. So this is a constant for this year. If I'm going to need to find it for just for the third year, so this is the total amount. If I wanted to have it further with another years, then it will have another value, which is the 20%. And then I can calculate both of them. Or I can do the same way. I can do it by the same way if I am trying to find, let's take it like that. Paste special. Okay. So here, if I'm going to use the same data, I'm going to keep this and I will remove the rest. Okay. if I'm going to use the first, second, and third, and then in the fourth year, this fourth year, which I said that it will be 4%, so I will say times 1.04, okay, giving me 252, and then I can remove this. The complicated one, it is adding 2 years, but if I'm going to based on the just the growth rate for the fourth year, so it will give me 2.52. So how much the value of the stock? The value of the stock, it will be the 2.52 divided by, what is the R? We said that the R in the market will be 14%. The R, it is 14%, and the growth rate, the other one is 4%. So I will divide it by a 10%. 14 minus 4. So it giving me 25. So here I can find the total amount of value here. It is $2 for the first year, 2.2, 2.75, and I can get the final answers here by saying NPV. So it will be equal NPV. I'm discounting it with a 14%, and that's it. So this is the final answer, which is 22.07. 22.07. If the problem stop like that, so it is 20, sorry, equal NPV, and the rate is 14%. And the values that we're going to receive here, okay, I need to add this one. So it is 2.2. Let's make it approximately. It's not accurate. To make it activated, I did something wrong. So it is 2.2. So it is correct here. So it is 2.2, 22.2, and it is similar to this one. So if I have two numbers of years, two different numbers of years, if I have two different numbers of years, did the complicated one, if the problem stopped like that, and he mentioned that for the third year only, and then you find to define the value of the stock for this year, if you see here. So what I did, I just, I find the value from the year that has been stopped. Let's do another one. So it is very simple. Let's go for another one. Another dividends, expected to pay dividends 1.5. No selling prices. Since there is no selling prices, this means, so it is to infinity. And the number of years is 4. So it is going to grow by 7%. So 1.5. And then 1.5. So I'm finding the future value with using 7% growth rate. 7% growth rate, 7% future value, and then future value 7% another 1 year. And he said that it lasts with me for 7 years. Oh, sorry, with the 4 years. In the 5th year, what's going to happen? The growth rate is going to be changed. What's going to happen to this growth rate? The growth rate is going to be changed. And here, so expected to pay dividends 1.5. So this is 1.5, and it will grow with the growth rate 7% for how many number of years? 1, 2, 3, and this is the 4th year. So it is expected after the 4th year that is going to change the 4th year is going to be changed with the new rate. So here it is 1, this 1.5, 1, 2, 3, 4. This is the 5 years, sorry, it is for 5 years. And it's going to grow for 5 years. Expected to pay dividends, and it will grow by 5 years. ادي 1.5 هتزيد السنة اللي بعديها الثانية 1 2 3 4 and this is the first. After this, we will have a new growth rate, which is the year where we are going to find the value of the stock to infinity. Here, use the constant growth model to find the value of the stock, and then you can do the discounting value. So here, I just add the stream of money that I'm going to receive, and then I can find it very easy by doing equal NPV, and the discounted rate, it is 15. And then I'm going to select all the stream values that I'm going to have. Then it will give me 20.62. So this is another way, instead of doing step by step. So it just in one click, you're using the NPV. Last one, let's go for it here. I'm just spreading it. So here are the years, here the growth rate. And in this growth rate, we find it using the constant growth model. So the rate is here, it is 7, because it is the last one, this is the 7, but here the last one, it is a change to 8%. So this 7, this is the 8%, it increases, and here I'm using a discounted rate. So here it is 32, and here, let's say, for example, if it is 1.5, he said the differences here is adding year 0. If I say, for example, the coming year, it will grow, and then you are going to calculate from the coming year or this year. So the only trick, it is in the 1.5, and that's all. So by this way, we did the 3 models of the common stock, the zero gross model, constant when we find the value of the stock, and then the variable gross model. Thank you, and best of success. Bye-bye.